Yuri and I here for round two of the common questions with some rhymes and flows that help you know, and other stuff that just doesn't rhyme at all. So probably won't go completely in order for what you've got up there, but in this assignment. But let's hit the big things here. So short-lived and widespread in a sedimentary rock bed. I'm going to cover Yuri's ears here. When fossils are found, they live all over the place if they're a good index fossil. They live for a short period of time if they're a good index fossil. So fossils like Yuri's cousins, they lived for a little bit of time. So that means if we find them short lived, we know exactly how old that rock is. But it also helps if they lived everywhere. So we can use that fossil to help date, figure out how old the rocks are. So if the animal lived everywhere or the plant lived everywhere for a little bit of time, that helps us figure out, we can pinpoint, oh, that rock is exactly that old because fossils like Uri are in there. The same thing goes for volcanic ash deposits. They happen really quickly, but they go around the world. Or meteorite impact deposits. They happen really quickly, but they go all over the place. So there's different ways to ask short-lived and widespread. Large geographic area is a term for widespread that's used a lot. Okay, so all of those things are time markers. They're index fossils. They're ways to figure out relative age of rocks. Rec, Schweck. If you could completely draw this when you sit down, we're going to go over different brain dump techniques. If you can have some things memorized at least long enough just to draw it all once you sit in the exam, this would be one of the very first things I'd tell you to do. Every single year it's on there, okay? They love asking different things. This is the cool and wet side. I should have wrote the exact vocab words down here. Windward on this side and leeward on this side. Okay, so on the windward side, rec, the air that starts here, it comes off of the ocean when it hits the Rocky Mountains. It starts to rise. Rising air starts out like this and it starts to expand. Anytime you let gases expand, that makes them start to cool off. And then condensation happens once things cool off. It'll hit the dew point, condensation, and then that makes clouds. So this rising causes expansion, causes cooling, causes condensation, causes clouds. That's what makes this the cool and wet side, because it's rising and cooling and raining. And then on the opposite side, what I do in my brain, I can remember rec and all of this stuff, and then I have to actually flip every single thing in my head. So I think, okay, what's the opposite of rising? Sinking. What's the opposite of expanding? Contracting. Cooling, warming, condensation, evaporation, clouds, and clear. So the Schweck side, this ends up being the warm and dry side. Sinking causes contracting. When you squeeze air up, if you squeeze a container of air, it's going to make it warm up and it's going to make it get clear, and because the water evaporates. Okay, so rec, schweck, definitely memorize one of those things. Wet side of the mountain, dry side. You've got to look. This only works for the direction that the wind is going. So in this diagram, the wind is going this way. You could completely flip the diagram and everything would be flipped. The windward side, if the wind was coming from this way, we'd have to do the mirror image of this diagram. Okay, very, very, very similar concept. Because of different specific heats. Okay, so land has a low specific heat that makes it heat up fast and cool down fast. Okay, so at nighttime, what's going to happen is land cools off really, really fast, so the air starts to sink over it, which is going to make it push out towards the water. Okay, water stays warm at nighttime, so in the summertime, the land air starts to sink and it blows out towards the water and it rises up and it circulates. This is convection. Okay, this is called a land breeze because it comes from the land. This is all about specific heat. Water has a very high specific heat. It takes a lot of heat energy to heat up water. You've also got to take a lot of heat energy out to cool off water. That's why water stays the same temperature for a long time. Okay, the exact opposite. During the day, the land has a really low specific heat. That means it doesn't take much heat energy to make the land heat up. So when the sun is shining, the land heats up really fast. It has a very low cost of energy, that specific heat. So that The land gets hot and the air starts to rise. That's going to pull the air off of the water, which makes it coming from the sea. It's called a sea breeze. And so this convection, air starts to sink over the water. During the day, since the land heats up fast and the water not so much, water stays cooler, land gets hotter. Low specific heat has a low cost of energy. Water has a high specific heat, so it takes a lot of heat, a lot of sunlight to make the water get warmer. Okay? A lot of different rotation versus revolution stuff, short term versus long term. So long term changes are based off of revolutions. Okay, the Earth's orbit around the sun, it makes changes that happen over many months or over a whole year. Okay, things like why do we see different constellations in January versus June? That's because the Earth is going around the sun. Why do we see anything happen like long term changes is a revolution or an orbit question. Short term changes. 1 hour I wait, 15 degrees, the Earth will rotate. Those are things that are based off of the Earth's rotation or the Earth's spin. On the last common questions, we dealt with the Coriolis effect stuff. Anything that happens in one day, stuff like that, is because of the Earth rotating, the Earth spinning. So sunrise and sunset, why do the stars move in the night sky? Anything about like one day's change, one night's change, 1 hour's change is because the Earth is spinning. So you see different stars throughout the year, a year, revolution. You see stars move in one night, rotation. That's because the Earth is spinning. Okay. The moon also comes into this once in a while too. Because the moon goes around the Earth, it revolves around the Earth. That's why we have the phases of the moon. Anything to do with going around is a revolution, and a spin is a rotation. And then www.ugg, okay, you're going to have to look up all the erosion and deposition features for this assignment in your review book. You've got to recognize them. Drumlins and alluvial fans and deltas and sand dunes. You got to know what agent put each of those things there. That's just a memorization thing. That's in your review book. But www.ugg, wind and water are almost always going to leave well-sorted deposits. www. Unsorted deposits are things, usually anything with glaciers or gravity leaves those things. So gravity was like mass wasting. Okay. So describe the sediment left behind. Any well-sorted deposits are almost always wind and water deposits. Glaciers, gravity, leave unsorted. Ugh. Okay. So you do have to memorize the features and look them up in your review book, but this helps organize your thoughts on describing sediments for that. I think we got everything. Yuri fell down. I got nothing else. See you later. I should have a good earth science joke to end with, but I don't.